Answers. One, the answer is 13/8. Two, wait, got it backwards. I got it upside down. No, I didn't. Yes, I did. Number one, the answer is 4. Number two, the answer is 13. Okay. This is very important. Solving for y. The key to graphing equations, the key to answering problems, the key to finding the slope of the y-intercept is to get y by itself. It's exactly the same as solving for an x. Get the x by itself, undo everything that's being done to the x. The only difference is you have two variables. You're going to have y by itself, and you're going to have everything that's not a y on the other side. So if there's an x and a y, you have y by itself, and the other side is going to have the x. So number 3, we're going to get y equals 3/2x minus 19. And on number 4, we're going to get y equals 3/2x plus 14. On number 5, we're going to get y equals -5/8 x plus 12. Number 6, we're going to get y equals 8/5 times x minus 12. And 7, we have y equals 2/3 x plus 38/3. And number 8, we end up with y equals 3/2x plus 19. Any question about 1 or 2? 1. Okay. You said 2 and you said 1. Okay. So number 1, and we'll get 2. Times 3 times x minus 4 equals 2x plus 3 times x minus 5. Okay, so step 1, when you're solving, you could simplify both sides completely. Don't try to solve it until you have both sides simplified. That means carry out order of operations. In the order of operations, parentheses should happen first. Inside parentheses, there's nothing we can do on either side because they're not like terms. But before you can subtract, you got to multiply. Got to multiply this 3. We're going to distribute, and you're going to distribute as a -3. Use the sign. So you bring the 5 down. And again, work the problem from left to right and bring it underneath from top to bottom. Don't, a little bit over here, a little bit down here, try to put it back into the problem. 5 comes down, -3 times positive x, -3x. -3 times -4, a negative times a negative, that's positive 12. As you distribute, say it. -3 times -4, that's a positive 12. Equals we have a 2x, and then distribute 3 times. Positive 3 times x is plus 3x. Positive 3 times negative 5, that's a negative 15. Now, here's where the biggest mistake happens. People start to try to solve it right now. They start to try to move everything from left to right and try to get everything instead of simplifying first. So if they do try to simplify first, it kind of comes apart right here. When we simplify this, you might want to have at least one consistent way of doing it. Gather all the variables and simplify all the variable terms. Well, the only variable term is this one. It's a negative 3x. So all my x's are that's one term with a negative 3x. And then the two constant is a 5 and a positive 12. 5 plus 12 on this side is a plus 17. So I simplify that left side. Combine all the x's. Well, there's only one term with an x. And then I have a positive 5 and a positive 12. That adds up to 17 on the left-hand side. Over here, the two x terms, 2x and 3x, got a 5x. And then there's one constant with a negative 15. So now both sides are cleaned up, both sides are simplified. Now we want to separate variables from constants. We want to get the variables on one side and get the constants on the other side. It doesn't matter which side you put the variables on, which side you put the constants on. You can bring all the variables to the left or take all the variables to the right. But what you want to do, you want to pick. If I take all the variables to the left, I would subtract 5x from both sides, and I would have a negative 3 minus the 5x. Negative 3x minus the 5x over here. And that's what you might want to do in your head is think about your move before you do it, just like you're playing checkers or playing chess or driving a car. Think about the move when you're driving a car. You got to look at the car ahead of you. And not just that, look at the car ahead of the car. That's going to determine what you're going to do. If I bring 5x to the left, subtract 5x, subtract 5x, the next move after that, negative 3x minus 5x is going to be negative 8x, which is no big deal. You're going to divide both sides by negative 8 at that stage. Think about the move that would happen afterwards. Or your alternative would be take the x's to the right. I would add 3x to both sides. So plus 3x, 5x plus, I would have a positive 8x. And then decide which one you want to do. But think about the move before you move. Do you want to take it to the right or bring it to the left? To the right. So don't just randomly do things. Think about what you're going to do before you do it. So we add 3x to both sides. On the left side, I still have a 17. On the right side, I have a 5x plus 3x, that's 8x, and a minus 15. And since we took all the variables, and all the variables are right here on the right side, I have to undo the negative 15, bring it over to the left. To undo a negative 15 or minus 15, I add 15 to both sides. So on this side now I have 32 equals positive 8x. So now I have a multiplication problem. Undo multiplication, we divide both sides by 8. 32 divided by 8 is equal to 4. In a solving situation, you can plug your answer in to see if it works. If I plug in 4, I would get 4 minus 4. What's 4 minus 4? 0. I would have a 0. What's 3 times 0? 0. So I would have 5 minus 0. So on the left-hand side, I just have 5. Okay. When I plug 4 into the left side, I get just 5. On the right side, I end up right here plugging in 4. 2 times 4, so that's going to be an 8. I have a plus. In here, What's 4 minus 5? 4 minus 5? -1. So I end up with 3 times -1. What's 3 times -1? So I end up with 8 minus 3, and 8 minus 3, I get 5. So when I plug in 4, I get 5 equals 5, and it works. Okay. Now, with fractions, when we're solving equations, you have the ability, you have the control, you have the power to undo the fractions. You don't have to solve the fractions or solve with the fractions. Fractions exist because they have a denominator. Fractions are just division problems. So to undo fractions, you want to multiply by the least common denominator and undo the fractions. That'll help simplify it, and that'll make it a lot nicer to work with. So on the second one, we have 4/3 x minus 5 over 12. And that's equal to 7 over 4. So I want to multiply every term by the least common denominator that's going to undo all three fractions. I have to multiply every term by the same number, and it wants to undo all of the denominators. So what number can those three denominators go into evenly? 12. That would be the smallest one. Now, I could go 3 times 12 is 36. And 36 times 4 is going to be 144. And I could use 144. Just multiply the three denominators together. You know what? I just have a bigger mess to clean up at the end. It'll work, but the numbers will be bigger. If I use the least common denominator, the smallest number, the first number that will work, I have less to do. So the first number that 3 and 12 go into, 3 goes into 12, and 12 goes into itself. So 12. And so now the least common denominator for these two is a 12. So now I'm looking at 12 and the 4. Well, 4 goes into 12. 12 then does everything. 12 will go into, or all three of those denominators go into 12 evenly. So I'm going to multiply each fraction. Everybody gets multiplied by 12. And when this happens, 3 goes into that 12, leaving 4. 4 times 4 gives me 16x. Remember, the point of multiplying everybody by the least common denominator is to undo the fraction. When I undo the fraction, I'm reducing the fraction by 3 going into 12, leaving a 4. 12 is 3 times 4. So when 3 goes in, there's a 4 left over. There's a 4 times 4 left in the numerator, which gives me the 16x. Minus. Here the 12 reduces completely. All I have left technically is a 1 times 5. 1 times 5 is just 5. Equals 4 goes into 12 3 times. 3 times 7, that's 21. No more fractions. Only works if it's an equation. Okay, versus an expression. An expression is what's 4/3 plus 5 over 7. No equals, no variable. We're not solving for x. So you don't have two sides to multiply something by. You have to get a common denominator and add the two fractions together, just like you learned way back when in the 5th grade. But when you have an equation, you have the ability to multiply both sides by the same number and undo the fraction, so you don't have to deal with it. Because now, all the variables are right here, so I'm going to take the 5 and put it over there, add 5 to both sides. And we get 16x. 21 plus 5, 26. Divide by 16. Always reduce to lowest terms. This is 2 times 13, and this is 2 times 8. You can reduce 2 over 2, so the final answer is 13 over 8. No decimals. Unless the directions tell you decimals, leave your answer as a reduced fraction. Don't change it to a mixed number. Just in case you get it wrong, you have the right answer right now. Is it improper? It's correct. And if you try to go one more step and change it to, well, that's equal to 1 5/8, just in case you make a mistake trying to convert it to a mixed number, that's what you think you're supposed to do. I'm telling you, don't. You have the right answer. Stop right there. And the reason why, if I have to take that answer and take it to another part of another problem, I'm going to need it as an improper fraction anyway. Well, let's just stop right there. Just make sure it's lowest terms. That reduces. Where we left off last Wednesday, we learned about the 5 different ways to write the equation of a line. What we haven't done yet is actually writing the equation of a line, which is the first quiz prep question. We'll do that at 10. But what I am going to do is give you the second part of what we got to finish is parallel or perpendicular. The way you tell whether two lines are parallel, perpendicular, or neither is you compare the slopes. That's why I gave you those 6 equations, and I wanted you to solve for y. When you get y by itself, when you have y equals on the left-hand side, the other side looks like this, mx plus b. Whenever you have y by itself, we are in slope-intercept form. Number 3 over there. Most important equation that you're going to see for linear equations. Because now if y is by itself, just by looking at the equation, the slope is the coefficient times the x, and the constant is the y-intercept where it crosses the y-axis. You can identify those 2 pieces so you know exactly how to graph it, where it goes. You know exactly how to compare slope between one and another. You know how steep a line might be or how shallow a line might be. Everything is in front of you, but you have to be able to get the y by itself. That's why positive 3 over 2x minus 19. This y ends up equaling 3 over 2x plus 14. This ends up being equals negative 5 over 8 x plus 12. And this one ends up being y equals positive 8 over 5x minus 12. Y is equal to positive 2/3 x plus 38/3. This y is equal to positive 3 over 2 x plus 19. I think those are the answers. Okay, first question. Any problem solving for y? Or do you just want to start with the first one? Okay. So if we start with this first one, 3x minus 2y equals 38. Here's the goal. What is y? That's what I want. Well, y all by itself. Okay. So that means I want to leave this on the left. I want to bring this over to the right. Since that's a positive 3x, I'm going to subtract 3x from both sides. Now, placement matters. I know you want to put 38 minus 3x, and it's not wrong. It is absolutely not wrong, but I've seen people do this. They don't get it right. It's not wrong. But what you have to keep going with, that's where the mistakes happen. We want this. Y equals the x term and then the constant last in order, because we have a job to do. We got to figure out what m is. We're on a search for m and b. So we want the x and then the constant. So on the left side, it's kind of like taking a little bit of inventory. On the left-hand side, we have this, and don't forget it's a negative 2y. Negative 2 times y equal to, on the right-hand side, we just put this, it's a negative 3x and a positive 38. It's like an inventory. What do we have on the right-hand side? Well, in order, we have the x term. So what do we have in terms of x? We have a negative 3x, and then the constant is a positive 38. By making a list, put the x first. Okay? Any question there? Last thing we have to do is solve for y. Y is being multiplied by negative 2. To undo multiplication, we divide. Now, here's what I know a lot of people will do. They'll say, all right, if I divide this side by negative 2, I'm going to divide that whole side by negative 2. Which, again, is not wrong, but it doesn't help us find what we want. We want individual terms, one term for the x and then the constant. We want them separate. So instead of dividing the whole side by negative 2, if I divide one term, I divide everybody by negative 2. Each term gets divided by negative 2. And that's actually going to help with simplifying. Okay. So now a negative over a negative, that's a positive. So I have technically I have 3x over 2. I'm going to write this out, 3x over 2. This is a positive over a negative, so that's going to be a minus. And then 38 over 2, well, that's 2 times 19 over 2. So it's going to be a negative 19. The whole point, however, is we want to know what the slope is times x. So I'm looking at this right here, and I'm reading 3 times x over 2. Somebody's going to say the slope is 3 because that's times x. 3 over 2, or 3x over 2 is exactly the same as y equals. This is 3 halves, or 3 over 2, and then times the x, and then a minus 19. That's when we go 3x over 2, that is exactly like having 3 over 2 times x over 1. Because you would multiply straight across. 3 times x over 2 times 1. So that's equal to x over 1 is just x. So that's 3 over 2 times the x. Okay, spelling counts. Spelling has to count. Because if you don't spell right, we're going to get the wrong answer. If you don't spell the correct word, it means something different. If you say they are going to the, they are going to go to the store, they're going to the store, and you write it. They're going to the store. That's not correct. That's not the right there. They are is they're going to the store. Two different, completely different meanings. So when you write the slope, this is not the same thing if you just go, oh, that's 3 over 2x. Because when I write that, it looks like x is in the denominator. And that just means you don't give a damn. I'm telling you right now, it matters. You need to be cognizant of what you write. Everything does matter when it comes to mathematics. The details matter. If you don't pay attention to the details, that's why we get things wrong. Went to my brother-in-law's funeral on Friday. My sister and him have been married for 50 years. 3 really weird kids. All different. All different. My nephew Nathan. Graduate valedictorian. Didn't know what he wanted to do. His dad, he's a really good trombone player, played for Federal State Band, but didn't know what he wanted to do. And dad pushed him into engineering. Go civil engineering. When it got tough, don't give up. Just kept crunching numbers. But my nephew Nathan doesn't really. He's kind of awkward with talking to people. So when he went up there and talked about his dad and how important his dad helped him with all these decisions, that's the first time I've ever seen Nathan actually open up a lot. And he broke it down with how lucky he was to have a dad like that in his life. He started breaking down all of the numbers in terms of out of the million people and all the billion people and how it was my sister and my brother-in-law met at Fresno City College like in 1972 or something like that. And there were so many students there, and it was this the percentage of them meeting with, when you start breaking into all the math. And then the chance of my brother-in-law catching or coming down with this disease was 0.8 out of every 1 million people in the world getting it. Actually, that was 0.08. It's like the odds are just so weird that there was this chance of his parents meeting, and then there was this chance of his dad getting this thing. So when he sat down, I go, nerd. But the details matter. They do. If you want to get the result, you want your accountant to pay attention to the details. You want your boss to pay attention, or whoever's running, the comptroller who's cutting the check to pay attention to the details. You want your doctor to pay attention to the details. So you can't hold other people accountable if you don't hold yourself accountable. And if you expect yourself to get through this, you have to start paying attention to the details. This is not acceptable. You may think, what's the big deal? But this is 3 over 2x. And that's not just so much about me not thinking this right. What I see students do with it, they treat it as 3 over 2x. So they forget what they just wrote down. I'm not just saying this because I think this is what you're going to do. I keep seeing this happen. Okay? So be careful. So when I did this, 3x over 2, it is 3 over 2 times x. So if you see this, it's technically this. You don't have to do this. You don't have to rewrite it as long as you recognize that is my slope. 3 over 2. Okay. So now, since it's in slope-intercept form, we now have the y equals m times x plus the b. So we now have the slope is 3 over 2, and the y-intercept is negative 19. Okay. Number 4 has got a little trick to it. Don't make it any more difficult than it is. This one tends to cause problems. You just want to get y by itself. And you like to read the problem from left to right. Y equals from left to right. So we prefer, if we're going to identify things, y equals. But over here, we have 28 plus 3x equals 2y. We have y on the right side instead of the left. But over here, y at least is starting on the left. If x is equal to 4, is it okay to say that 4 is equal to x? Does that mean anything different? No. It's the same equation. It's the same equals. I can flip equals with no big deal. That is the symmetrical property of equality. If A equals B, then B equals A. It doesn't matter which side, as long as it's equals already, you can interchange the sides. So I can interchange the sides right now because I just have the 2y. I can go, all right, this is just 2y equals 28 plus 3x. Or I could just solve for y right now and then flip it around when I'm done. But the first thing is, don't panic. You're just solving for y. So right here, if I just want to solve for y, all right, over here, I have 28, I have the 3x. 2y is all by itself. The only thing being done is multiply by 2. So I'm going to divide. Everybody gets divided by its own 2. So I get 14 equals okay, plus 3 over 2 times x equals y. So if I come down here, y equals by itself. The x term should go next, so 3 over 2x. And then I have a positive 14. So what do I end up with? There's y by itself. Then I have equals. What do I have in terms of x? I got a 3 over 2x. And then what's my constant? It's a positive 14. If I flip it first, so the 28 plus 3x goes on the right, the 2y came over to the left, divide everybody by 2. Get y equals at 14 plus 3 over 2 times x. And then just realize you would prefer the x term and then the constant. So now we know the slope is 3 over 2. And the y-intercept is 14. The whole idea, get y by itself. Number 5, we want y by itself. X is already on the other side, so y and x are both separate. So we're going to keep y on the left. We just have to take the 96 and put it on the right. What am I going to do to get the 96 over? Subtract 96 from both sides. So I'm left with a negative 8y equal to, again, x and then the constant, so 5x and a minus 96. And then to solve for y, everybody gets divided by that negative 8. So that gives me positive y equals a positive over a negative is a negative 5 over 8 times x. A negative over negative is a positive, and 96 divided by 8 is 12. This is 8 times 12 over 8. I'm just left with a 12. So on the sixth one, we get a y by itself. Well, it sounds creepy a little bit, y by itself. Sounds, I mean, just like been saying it for I don't know how many years, we'll get saying it for 30 years plus. We'll get y by itself. What do I do first to isolate the y?
Subtract the 8x.
Subtract 8x from both sides. Subtract 8x, subtract 8x. Negative, that's still negative 5y. We're going to get that negative 5y. On the other side, x term, so the negative 8x, and that's a positive 60. So it's separated, so now what's going to happen? You divide it by 5. Everybody gets divided by its own negative 5. So divide by negative 5, divide by negative 5, 5. We get y equals negative 8 over negative 5 is 8/5. Positive 8 over 5 times x. Positive 60 over negative 5 is negative 12. So real quick, this slope is negative 5 over 8, and the y-intercept is 12. This slope is positive 8/5, and the y-intercept is negative 12. Negative 5/8, positive 8/5. That's going to be very important when we continue on with the lecture at 10. That tells us a big, big, big conclusion. What I'm going to do, first thing I need to do to get y by itself, calculate x, subtract 2x from those. Be careful with the negative. That's a negative 3y left on the left side. On the right side, it's a negative 2x and a minus 38. And then everybody gets divided by its own negative 3. Keep track of your signs. Negative over a negative, that's a positive, and we're left with 2/3 times x. A negative over a negative, that's a positive, 38/3. So the slope here is 2/3 times x, and then plus 38/3. The y-intercept is 33. Every time solving for x, solving for y, I want x separated from the y. So y by itself, whatever, if there's multiplication with the y, that doesn't matter. We're going to keep it on this side. So the y term by itself, and then we undo multiplication. So over there, what do I do first? Subtract 3x. Same process. Subtract 3x. And we end up with a negative 2y. If it was a plus 2y, then it'd be plus 2y. But it's a negative 2y. And I kept putting negative because what gets lost from left to right, from second step, first step to second step, is that negative. So negative 2y equal to a negative 3x and a negative 38. And then we get y. Everybody gets divided by negative 2. Positive y, negative 3 over negative 2, that's positive 3/2 times x. A negative over a negative, that's a positive 38 divided by 2 is 19. So the slope here, the slope is 3/2. The coefficient of x and the y-intercept is 19. The whole point is so we can identify the slope and we can identify the y-intercept. Most importantly is identify the slope. Now, every time I wrote down the slope, you see how all I wrote down was the 3/2. I did not put x. The slope is the coefficient, not the x. X and y are the ordered pairs that are on the line. The slope is just the coefficient of x. So if you put an x here, you're going to lose a point because x is not part of the slope. Over here, it was just the 3/2, the coefficient of the x. Negative 5/8. There's no x here when you write down the slope in all cases. Every case, all cases. Okay. Special cases. Last thing we did last week were the 2 special cases. To identify the slope and the y-intercept in those two special cases, what can we get? What kind of line is this first one? Positive. What kind of line is it? Has special name. Special case, special name. The two special cases are what kinds of line? Vertical. Vertical and horizontal. Horizontal. Which one is this? Vertical. No. Oh. This is the horizontal line. Y is always a 5. Y is always a 5. So do you see how there's no X? Y is by itself. Y equals M times X plus B. Since there's no X, this must be the what? B. That's the B. If there's no X, what would M have to equal in order for X to disappear? 0. It would have to be Y equals 0 times X and then a plus 5. Which means the slope of this horizontal line, which we went over, all horizontal lines always have a 0 slope anyway. You can't spell horizontal without a O, slope of the horizontal line is 0. Okay? All horizontal lines, slope is 0. And then the y-intercept is going to go through the y-axis right here through 5, if it's horizontal. If this was a -2, then the y-intercept would be -2. And it would be down here. Because it has to go through something. Now, the vertical line, x equals -2. What's the slope of a vertical line? What letter comes right before V for vertical? What letter comes right before a V in the alphabet? X. XV? U. UV, right? So what slope is vertical line? U. Undefined. The slope of a vertical line is undefined. Because when we calculated the slope of the vertical line, the run was 0, so the fraction had a 0 in the denominator. And you can't divide by 0, so vertical lines have an undefined slope. If I graph this, it's a vertical line right here at -2. Is it ever going to cross the y-axis if it's going to -2? So the y-intercept, it doesn't have any. That's why there's special cases. And if you recognize that there's special cases, it takes, 3.5 seconds to graph it. But you got to recognize when it's x by itself, it's vertical, through that, whatever that number is. When it's y by itself, it's horizontal, through whatever that number is. Okay. Well, coming on back at 10.